Abu Bakr ibn Muhammad ibn al-Hussein al-Karaji was a Persian mathematician and engineer who has made massive contributions to the development of 10th century mathematics. Al-Karaji was born in Karaj, a city near Tehran in modern Iran, but has flourished and written many of his works in Baghdad. Among the first contributions of Al-Karaji in the field of mathematics was to free algebra completely from geometry. What Al-Karaji did was he abolished the need for geometrical representation to solve algebraic problems in mathematics. He said that polynomial expressions could be added, subtracted, multiplied, and divided using the same algorithms applied to operations with numbers without any reference to geometry at all. Without the contribution of Al-Karaji, people nowadays who deal with applied mathematics has to construct geometrical representation when they deal with higher degree polynomials. Of course, this is very tedious and difficult to do. Now, the other contribution Al-Karaji made was in the development of binomial theorem. Al-Karaji dealt with the problem of expanding binomials that are being raised by an exponent greater than 2. For example, if you want to expand the binomial a plus b raised to the power of 4, we look into the fourth column in Al-Karaji's table and look at the binomial coefficients. The binomial coefficients stated in the column are 1, 4, 6, 4, and 1. We may use these binomial coefficients to find the expanded equation of a plus b raised to the power of 4. With this, we can cut short a lot of operations if we do it the traditional way. This development in binomial theorem has many applications in mathematics and economics. One of the applications is to find the Euler's number E equal to 2.7182. The other economic application is to use binomial theorem for economic predictions. Economists use binomial theorem to find the probability of growth for an economy in a nation.
Assalamualaikum warahmatullahi wabarakatuh. My name is Fathia Abdul Malik and this video is about Al-Tusi and his contribution in trigonometry. So to begin with, we will start with the little bit of the biography of Al-Tusi. Al-Tusi was born in Iran in February 1201, and he was one of the great scholars that covers many areas of knowledge such as astronomy, and did a very famous invention in that area such as the invention of Tusi couple on how the circular motion can create the linear motion. And the second contribution was on mathematics area, and the third one was on the philosophy area, and many more. So he was died in near Baghdad in June 1274 at the age of 73. So for the specific contribution in mathematics, he had contributed particularly in trigonometry, as he was the one that separate the trigonometry as one of the pillar in pure math rather than involves as a tool in the discussion of astronomy. And also in this trigonometry area, Tusi had continued to develop the spherical triangle, where he invented one of the formula of the spherical triangle that was the sine formula that we use until now. And this formula can be found in his first book on the essence of math in trigonometry, Shakl al-Qata, or treatise on the complete quadrilateral. So we can see the application of trigonometry in economics by putting the sine function trigonometry graph with the business cycle graph, where they both share the same characteristics, which we will see in few seconds. So firstly, they both are continuous in nature, as the business cycle have the same wave curve as the sine function trigonometry graph. Second one is that both the shape of the curve are repeated every one full wave. And thirdly, both of the graph have maximum and also minimum value at the true and the peak, which in the business cycle graph, they indicate some economics interpretation at that point. So I guess that's all, and I hope you benefit something from this video, and Assalamualaikum.
In description, let's jump to video. Al-Biruni was born in September 5, 973 in Khwarezm. His first 25 years were spent in Khwarezm, where he studied fiqh, theology, grammar, mathematics, astronomy, medics and other sciences. The end of the 10th century was the age of the social unrest in Islamic world. Thus in 995, he left for Bukhara, and in 998 he went to the court of the Ziyarid Emir of Tabaristan, where he wrote his first important work, Al-Athar al-Baqiya and Al-Quran al-Khaliya, on historical and scientific chronology. In 1017, al-Biruni was taken to Ghazna by Mahmud Ghaznavi. Biruni was made court astrologer. After Indian invasion, he was sent to India for a few years, where Biruni became familiar with all things related to India, even Sanskrit. During this time he wrote the Kitab Tariq al-Hind, around 1030. Al-Biruni was one of the greatest scholars of the medieval Islamic era, and who contributed to physics, mathematics and astronomy, geography, pharmacology, mineralogy, history, chronology, religion and ideology. He was aware of different languages: Persian, Arabic, Sanskrit, Greek, Hebrew, Syriac and Berber. He recorded observations of his travels of India in his book Kitab al-Hind, which gives an account of the historical and social conditions of the subcontinent. He translated 2 Sanskrit books into Arabic. He regarded the Indus Valley as an ancient sea basin. On his return from India, al-Biruni wrote his famous book Qanan-i-Masudi, in which he discussed several theorems of astronomy, trigonometry, solar, lunar, and planetary motions and relative topics. His other book Al-Athar al-Baqiya was account of ancient history of nations, with geography. In this book he also discussed the rotation of the Earth and has given correct values of latitudes and longitudes of various places. He also wrote the Kitab al-Saydana, about medics. His book the Kitab al-Jamahir deals with the properties of various precious stones. Al-Biruni discussed, centuries before the rest of the world, that the Earth rotates around its axis. Or his book al-Tafhim li Awal Sina'a al-Tanjim gives a summary of mathematics and astronomy. He was the first to undertake experiments related to astronomical phenomena, which laid down the early foundation of modern science and astronomy. He explained the working of normal springs and artesian wells by the hydrostatic principle of communicating vessels. He observed that flowers have 3, 4, 5, 6, or 18 petals but never 7 or 9. His important work was the method of determining the radius and circumference of the Earth. Al-Biruni wrote about 200 books and made a few instruments for astronomy. The illustrating method proposed and used by Al-Biruni to estimate the radius and circumference of the Earth laid the foundation of modern astronomy and became the base of astronomy. Al-Biruni was a pioneer in the study of comparative religion. He studied Zoroastrianism, Judaism, Hinduism, Christianity, Buddhism, Islam, and other religions. In Tariq al-Hind, he explored every aspect of Indian life, including religion, history, geography, geology, science, and mathematics. He has been considered as one of the very greatest scientists of Islam. His critical spirit, love of truth, and scientific approach were combined with a sense of toleration. He died in 1048 AD at the age of 75, after having spent 40 years in thus gathering knowledge and making his own original contributions to it. Make sure to subscribe us. Follow us on Instagram and Twitter, link is in description.